Force between the plates of a capacitor, problem number 4. Charged capacitors A and B have their outer plates fixed and inner plates connected by a spring of force constant K. The charge on each capacitor is Q. Find the extension in the spring at the equilibrium. Okay, now we have seen in the chapter of springs in mechanics, ideal spring is massless, okay? And suppose it is acted upon by a force F this side and F this side. So the net force on the spring would be 0. Remember, we have seen these things in the fundamentals of the springs. Of course, the net force on the spring will be 0, but the pulling force is not 0. Because one force will make the spring as a barrier support, another force would be pulling. So here, the pulling force is F. And so this pulling force will elongate the spring, and the elongation would say is X. So you can write F is equal to what? Kx. Okay. The elongation in the spring is always because of the pulling force, not the net force. In the spring articles, we have paid very much special care that there is a difference between the net force acting on the spring and the pulling force. Now let's see, here we have two capacitors. So each capacitor has a charge Q. So this plate, say the capacitor A, right plate of the capacitor A would be getting attracted towards the left side with the force F, and the left plate of the capacitor B would be getting attracted to the right side with the force F. Since both the capacitors have the same charge and same area, the magnitude of the force is same for both the plates, that is Q square by 2 epsilon naught A. Got it? So what will elongation in the spring? So spring would be acted upon by two equal and opposite forces. Of course, so net force will be 0, but there will be an elongation in the spring because elongation will be decided by the pulling force. So the pulling force is the electrostatic force, which can be equated with Kx. So I'll get Q square by 2 epsilon naught A is equal to Kx. So you the elongation will come to be Q square by 2 epsilon naught A K, and that is the answer to this problem. Got it?